right, we're going to move on to the next section. This is 3.2 in your textbook. We have to refresh a few things about parallel lines before we move on. Your notes will be your homework, so make sure you're taking good notes as we go throughout. If you need more time to copy things down, remember you are in charge of pressing pause and pressing play, whatever you need in order to get all of the notes down. So please go ahead, copy down this refresher slide about what we knew before if we had parallel lines. So if I had parallel lines, I knew that alternate interior angles were congruent, alternate exterior angles were congruent, same side interior angles were supplementary, and corresponding angles were congruent. Those four things I knew if I was given parallel lines. Now today we're going to be talking about the reverse. Okay, when we're talking about the reverse of what we've learned before we knew that if parallel lines, that told me corresponding angles were congruent. Now we are going to flip-flop, and that means we're going to do the converse. The converse switches that hypothesis with the conclusion. So go ahead, copy down everything that you see, including that diagram, please. It's up to you. If I'm going too fast and you need more time to write things down, remember, pause and play when you're ready. Alright, looking at this diagram here, I have angle 1 and 2, and they are corresponding angles. So if I'm given that angle 1 is congruent to angle 2, that is enough to show that I have parallel lines. Because if corresponding angles are, oops, I should have the symbol congruent there. Let's add that in. If corresponding angles are congruent, then I have parallel lines. So which lines are parallel here? Well, L is parallel to M. Alright, on to the next converse. Okay, the next converse is about alternate interior angles. Copy everything down you see, including the diagram. So the converse of the alternate interior angles theorem says if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. Looking at my diagram here, I have three different angles. Which ones are alternate interior angles? I hope you are saying to yourself, angle 1 and angle 2. So let's say that I'm given that angle 1 is congruent to angle 2. So if alternate interior angles are congruent, that is enough to show parallel lines. And if in this specific diagram, what lines would be parallel? Well, L would be parallel with M. Alright, on to the next converse. Okay, the next converse is about alternate exterior angles. I'll give you some time to go ahead and copy everything down. So like before, If I know that 1 and 2 are alternate exterior angles, which they are given the diagram, and I know that 1 is congruent to 2, and they're exterior angles, if alternate exterior angles are congruent, that tells me I have parallel lines. In this diagram, which lines are parallel? Again, L and M. Alright, one more converse to talk about. I'm sure you can kind of guess which one it is. Okay, the last converse we have to talk about is the converse of the same side interior angles. Go ahead, copy it down. So remember, same side interior angles are a little different, right? So the converse is if two lines in a transversal form same side interior angles that are, keyword, supplementary, then the two angles are parallel. I'm sorry, the two lines are parallel. So if you notice at this picture, 1 and 2 are same side interior. So if I know that 1 and 2 are supplementary, that tells me that I have same side interior angles that are supplementary. So that's enough to prove that I have parallel lines. And according to this diagram, which lines would be parallel? L and M. Okay, now we're actually going to look at some examples. Go ahead, take some time to copy down the directions in all 4 pictures. Okay, my directions say, can you prove that P and Q are parallel? If so, describe how. Looking at this first picture, what am I given? I'm given these angles are congruent. Well, what kind of angles are those? If you look at the picture, they would be alternate exterior angles. So if alternate exterior angles are congruent, that's enough to tell me that I have parallel lines. So yes, P is parallel to Q. Looking at B, well, what is given to us? What angles are congruent? Remember, these are vertical angles. Are vertical angles one of our 4 theorems? One of our 4 converses? No. Vertical angles do not tell me anything about parallel lines. So can you prove that P is parallel to Q? No. Okay? Looking at C. Well, what's the relationship between those given angles, those 105-degree angles? That it looks like that they're corresponding. So if corresponding angles are congruent, that tells me I have parallel lines. So yes, P is parallel to Q. Alright, in this last one, they look like the 123 degrees and 57, they're same side interior. So I have to check, are they supplementary? Well, 123 plus 57 is 180. So if same side interior angles are supplementary, that proves that I have parallel lines. And again, we could say yes, P is parallel to Q. Okay, let's look at another example. Okay, go ahead, write down the next example. Okay, it says which lines, if any, must be parallel. Well, look I have 4 lines here. Across here is EC, here is DK, and then up and down I have ED and CK. So I want to see if any of these lines are parallel. Well, if I know that angle 1 is congruent to angle 2, if we look here, these are in the position for alternate interior angles. So I have to figure out which lines would be parallel. The lines always have to touch them. They have to touch my angle. So it looks like it's this line here and this line here. So which lines would have to be parallel? ED would have to be parallel to CK. Alright, angle 3 and 4. Let me erase what we have drawn on the picture here. So now we're looking at different set of angles. We're looking at 3 and 4. So here is 3 and here is 4. Well, looking at these angles, it looks like they're corresponding angles, correct? So which lines would have to be parallel? Remember, the parallel lines have to touch them. So here, this line, EC, would have to be parallel to DK. So let's write that down. EC would have to be parallel to DK. And then let's check about our last set of angles. 1 and 4 have to be supplementary. Okay, look at where 1 and 4 are positioned. 1 and 4 are supplementary, and those look like they're same side interior. So which which lines would have to be parallel? Remember, ED and CK would have to be parallel. Do you see how? Well, let me write this down first. ED, let me make that clear. ED would have to be parallel to CK. In this last example, do you see how this line, EC, doesn't even come close to touching those angles? So that should not be even in our running for sets of parallel lines, okay? The angles that were given, the parallel lines have to touch them. So make sure you are creating the correct parallel lines. All right, let's look at another set. Okay, now we're going to look at the same thing, but now we need to justify our answer with a theorem or postulate. Go ahead, copy everything down you see, of course including the diagrams. Okay, in this first picture, this is kind of tricky. If you notice, we have all interior angles. They're all on the inside of my parallel line. So I have to check. They all look like they could be same side interior. In order for same side interior angles to prove parallel lines, I need them to be supplementary. So let's check this sum. Let's add up each set of angles. If I'm looking at 115 and 65, okay, 115 and 65. If I add those together, do I get 180? You bet I do. So, which lines would have to be parallel? Well, let's look here. The lines have to touch the angles. So, would it be R and S? No, S doesn't even come close to touching these angles. So, it would have to be that M is parallel to N. When I add 75 and 105, does that equal 180? Yes. So that confirms it. I know that M is parallel to N, and the theorem or postulate would just be if same side interior angles are supplementary, that is enough to prove that I have those lines parallel. Oh, parallel lines. Okay? So I can really, let me erase everything on this picture. So I really can put some arrows on this diagram. Let's check our other angles. When I add 115 and 75, do I get 180? No, that's 190. So those are not going to be supplementary. How about 65 and 105? Well, that's 170. So is R parallel to S? No. Since those angles were not supplementary, the only conclusion I could make was the one we just did. M is parallel to N. All right, let's look at this second example. Let me make these angles a little bit darker. This says 87. This says 125. And down here I have 93. Again, all of these angles are on the inside of my parallel lines, or what we're looking at to be parallel lines. If I add 87 and 125, am I going to get 180? No. How about 87 and 93? Yes, those two angles there, 87 and 93, are supplementary. So which lines would have to be parallel? Remember, both lines have to touch the angles. So in this one, AC would have to be parallel to BD. Do you see why it would not be AB and CD? CD doesn't even come close to touching those angles, so that would not even be in our running for the set of parallel lines. To justify, it would be the same justification if same side interior angles are supplementary. That will show us we have parallel lines. All right, good. Let's look at a few more of these. Okay, let's look at another one of these pictures. Go ahead, take some time and copy down that diagram. The directions are the same from before. We want to determine which lines are parallel, if any. Okay, if you notice which angles are given, they look like they're in the position to be corresponding angles. If I extend these lines That should help with our visual of determining which lines are parallel. So do you see how BC touches that angle and ED touches that angle? Those are the sides, those are the lines that would be parallel. And how do I know that? If corresponding angles are congruent, that tells me I have parallel lines. And in this example, BC is parallel to ED. Alright, let's look at some algebra. Okay, now we're going to talk about the algebra with this section. Go ahead, copy everything down you see. Alright, it says find the value of x for which A is parallel to B. If I want to, in this first diagram, letter A, show that A is parallel to B, look at the angles that I'm given expressions for. These angles are alternate interior. So if alternate interior angles are congruent, that's enough to show parallel lines. So how am I going to find the value for which A is parallel to B? We're going to set them equal. So I get 14 plus 3x equals 5x minus 66. So we're going to subtract 3x from both sides. So I get 14 equals 2x minus 66. Add 66, so I get 80 equals 2x. Divide by 2, so x would equal 40. Looking at this next diagram, think to yourself, what is the relation between that 2x and the x? Well, they're same side interior. In order to show that these lines are parallel, same side interior angles have to be supplementary. So we're going to add these up and set them equal to 180. 2x plus x is 3x. Divide by 3. So x equals 60. This last example is a little bit more complicated. There is no direct relationship between this angle here and this angle here. So I need to kind of use my thoughts and knowledge of parallel lines cut by a transversal and the angles that they form. Well, remember, if this angle is 40, isn't this angle 40? So now I have same side interior angles, and in order to show A is parallel to B, those would have to be supplementary. Okay, if I combine my terms, I get 2x plus 46 equals 180. Subtract 46 from both sides. So I get 2x equals 134. Divide by 2. Divide by 2. So x equals 67. Alright, we have one last example we got to look at. Okay, go ahead, draw this diagram. This is our last algebra example of finding the value of x such that A is parallel to B. So if I'm trying to show A is parallel to B, If this angle is 2x minus 75, this angle also would be 2x minus 75. Why would we know that fact? Because these are alternate interior angles, and if I'm trying to show that the lines are parallel, then those will be congruent. Alright, now, how the heck am I going to solve for x? Do you notice anything about these three expressions? Hopefully you're saying they create a straight line. They are supplementary. So how am I going to solve for x? I am going to add them all up, and I'm going to set them equal to 180. So combine like terms, and I get 5x. When I combine my constants, I get minus 60 equals 180. Go ahead, add 60 to both sides. 5x equals 240. Divide by 5. So x equals 48. So the value that makes A parallel to B is 48. So go ahead and make sure that you took good notes because this is your homework. There'll be no homework tonight other than your notes. If you did not understand some of these examples, I ask tonight at home that you go through this lesson again and go through the examples that gave you trouble. Where can you find this presentation? On my teacher website. So go ahead, go to the Tinley Park website, click staff, click Miss Canning's name, and it'll be on that left-hand side of the page. All right, I will see you all tomorrow.